What's up everyone, Bryan here. Welcome back to my channel. In this tutorial, we'll be going over how to prove ownership in Pact. We'll be looking at key sets. We'll first go over how identity is proved in crypto, then how this is done in Pact. Lastly, we'll be writing some code to use what we have learned. Same thing as the last tutorial, we'll be using only REPL today. Firstly, let's go over how you can prove identity in crypto. In crypto, we have public and private key pairs. You can go back to the first tutorial in the series if you'd like to know more about this. The public key is like your account ID and your private key is your password. Whenever you interact with the blockchain, your wallet uses your public and private key to authorize the transactions you are doing. Please note, it never actually sends the private key to the blockchain. Instead, it uses it to sign transactions you send. You don't need to know how it works, but in summary, it's a way to prove that you have a private key, but without sending the private key. This approach is generally limited to allowing one person to authorize things at a time. But sometimes we might want a group of people to authorize things. Let's say you made a project with your friends and you want the equivalent of having a group account to be able to do things on the blockchain. You may have heard of the term multi-sig before. This is pretty much what it means. For these scenarios, Pact provides the concept of a key set. This is essentially just a group of keys that can be used to authorize interactions with the blockchain. Now with that out of the way, let's make our own key set and write code. To create a key set, we need to do the following steps. Log in to Chainweaver, navigate to contracts, click on the env tab, expand the data section, and type in your key set name. Please choose something that no one else would have chosen, as this must be unique. Click Create. Choose the signing policy. Just choose keys all for this tutorial to keep things simple. You can learn about those later. Select the keys you want to sign by ticking the box. Now, the last part. Let's write some code. First of all, the key set we just made is only stored locally. It's not yet shown onto the blockchain. To do this is pretty easy though. Just open up your REPL and type the following code. Remember to replace test key set with the name of your actual key set. So my key set is testing 1, 2, 3. I'm replacing them with testing 1, 2, 3. What we are doing is calling a function on the blockchain called define-keyset. We then tell it what the key set should be called on the blockchain. We then provide the actual key set data to store. This is done by calling the read-keyset function. Chainweaver is smart enough to realize that you have your key set locally. So it will load up the key set from your local environment and use that value. The final step is to verify things. We can do things like this. This calls the enforce-keyset function. It then reads the test key set and verifies that you are passing the key set authorization. It should show true on the screen to indicate you passed the check. Another way to do this, and this is the recommended way to use the enforce guard method. This is a fancier way of checking key sets that allows your code to work with key sets and also with other more advanced ways of doing authorization. I won't get into its benefits in this tutorial, but you should make it a habit to use enforce guard to check for things. Now, type this in. Again, remember to replace test keyset with the name of your keyset. So, in this case, I'm replacing test keyset with testing 1, 2, 3. And the return value will show true. That's it for this tutorial. We are almost ready to write a full smart contract. If you have any questions from this tutorial, do remember to join KittyKad's Discord, and we have a programming channel for discussion purposes. Otherwise, remember to help hit the thumbs up button, comment and subscribe to my channel. Thank you for watching, and I'll see you in the next video.